Okay, welcome back, guys and girls. So what I got today, I got a power supply board out of a 52-inch Samsung, okay? And this is the Samsung with the class action lawsuit, one of those from back in like 2000, and I'm not sure, I believe this one was probably manufactured in around 2013, maybe, or 12. And the model number of the TV is an LN52a, as in alpha, 540p, right? And this part number on this board is a BN44-00200A, okay? And what the TV is doing was a totally dead set, all right? No standby light, no nothing, just dead, okay? So obviously when the TV was in the customer's home, the first thing that I did do is check the standby voltage, okay, which is located right here on this plug, and with this connector, which is where the plug goes that is going to the main board. Right? Pin 3 is the standby voltage should be at 5.1 volts, okay? So that is voltage that should be there as soon as you plug the TV into the wall, okay, even without turning it on, all right? You should have the 5-volt standby going to the main board so the main board can turn the TV set on via the power button or via the remote control. So all the even numbers, 2, 4, 6, 8, 10, 12, all the way down are up top, and where the 2 is at right there, and these ones here facing me are 1, 3, 5, 7, 9, etc. Okay, so pin 3 will be right here. Okay, so I guess I gotta get a power cord first, right? I never thought about that.
Chi-Town's finest.
Today's video is being sponsored by PCBWay. PCBWay is one of the world's leaders in printed circuit board production, manufacturing, designing, and prototyping. All you do is just send them your project information, and PCBWay will design and print any quantity of circuit boards that you need. They will also place electronic components on the boards for you. Boards start at just $5 a piece. You can choose the PC board material, multiple layer boards up to 14 layers thick, and even flexible circuit boards. With their CNC, injection molding, and 3D printing services, they can also manufacture your entire project from inside to outside. Just go to PCBWay.com and register today to receive a $5 welcome bonus and more. So now, let's get busy. Okay, so that connector that's going to the main board is always on the cold side of the power supply, okay? Now, the cold side and the hot side of any switch mode power supply is always separated by a line, okay? This white line here, okay? So you know which is cold and which is hot. Now, I do have a video on power supplies, so if you're kind of unfamiliar with how this thing works, make sure that you do watch that video and you'll get a whole lot better understanding of it. But believe me, no matter how people hype up a switch mode power supply, it's really easy, right? If you just know how it works, right? Now, your AC plug that's going to the wall, okay, is always on the hot side of the power supply, okay? So, and as you can see, it is on this side of this white line, right? Which is going down here, through here, and through here, and through here, right? So you're always gonna have to use different grounds. You have to use hot ground when checking anything on this side of the line, and you can use cold ground, or if the TV is still, if the circuit board is still in the TV and screwed in, right, via these metal ground plates right here, where the screw is at, you can use the chassis as ground, or anything like this tab right here. Okay, that's ground, cold ground. Okay, so hot, cold, primary side, secondary side, 5.1 volts DC. Okay, all these voltages here are DC, standby. All right, so let's turn it around. Pin 3 now is where you see my blue marker, my blue mark right here. Okay, that is the standby pin, pin 3, 1, 3, 5, 7, 9, 11, 13, so on and so on, all the way to the end, right? Okay, as you can see the separation from the primary side and secondary side, or hot side and cold side, better on the bottom of the board. You can see this black line, okay? All right, as you can see, our plug is going here, and our hot side, all this is hot side, all the way up to here, and this is secondary side. And this board uses, this TV, should I say, uses a standard inverter board. This is a LCD, not a LED, CCFL lit TV. Okay, so it does have some more connections for the inverter board and stuff like that. So we're concentrated right here for right now on this plug, the 5 volt standby, right? A warning, when you're handling boards by itself, be very careful about these big capacitors right here, okay? Do not put your hands in the middle of the board or anything on the primary side, okay, on the hot side, because they still hold a charge, okay? And don't worry if you get shocked, it won't kill you. but you might pee on yourself, okay? No, I'm just joking, though. But anyway, but you will feel it though. Yeah, you will say ouch. Trust me, you will let out some words out of your mouth that you don't want me to say right now. But anyway, as you can see on the secondary side, where's our plug at? Down here. Okay. You can actually ground it. You know, any one of these metal tabs, right? Okay, that is still all secondary side, okay? And I'm going to just turn it back around. So the pin number 3. And I have absolutely nothing. And if you want, sometimes these boards are not marked with the legend on the connector that goes to the main board. So if you get a dead set, just check all the pins, okay? You know, you're not like, okay, I don't like you're like confused, like I don't know which one is the standby. So just check all the pins, okay? If you got the 3.3 volts and it's steady, or 5 volts and it's steady, okay, make sure it's steady first. It's not, the standby voltage is regulated, okay? So it should not be jumping from 5 to 4 to 3. All right, because that will trick you into thinking you got standby. Well, actually, you got a problem on power supply board. Now, just take note, if you have a TV that's dead, okay, like this one, and I did have the 5 volts there, okay, and it was steady, or any TV that has a steady standby voltage, but the TV is totally dead, that means there's no standby light, nothing. It's just like the TV was unplugged from the wall. If you do have the standby voltage, it's a good chance you have a bad main board, all right? Okay, and there's ways to check that too. You can always check the control panel. You can check see if it's getting voltage on either the pins that's coming from the keypad or the IR sensor. There should always be voltage there, even when the TV is off, as long as it's plugged in. Now, I still got this plugged in, but just, yeah, be careful when you're doing this, which I'm touching the edge of the board. And I'm gonna do next is my meters in DC volts. I'm going to check voltage across these filter capacitors, okay? That most likely lets me know that my fuses are good. Now you can check the fuse first if you want, but I'm gonna go right here. It doesn't matter, you can put negative on, but I just put negative on negative. It doesn't matter, you're gonna get a negative reading. But I should get approximately, if the TV's not, if the power factor correction circuit is not kicking in, or the TV's not powering on automatically, I should only get about 160 volts. All right, there we go. 167, and it looks pretty steady. Okay, I know it's jumping a little bit, but that's not a regulated, it's not truly regulated, it's just rectified by the bridge rectifier. Okay, so that's a good sign that everything that's from the power connector through the bridge rectifier, which is this bridge rectifier dial right here, is good. The next thing I'm gonna do is find out where is my switching transformer. Okay, now as you can see, we have a lot of transformers on here. Okay, we got 1, 2, 3, 4, 5, and then one here looks like 6. Okay, am I doing that right? Yeah, 6. Okay, now what you want to do is look for the transformer that one side of the transformer is on the primary side and one side is on the negative side. I'm sorry. One side of the transformer is on the primary side and the other side is on the secondary side. So the transformer with the line, the separated line is going through it. Okay, so that will be this one. All right, as you can see, the line is going through that, and we'll do have another one right here. Okay, these are our power factor correction transformers that turn on when the TV is powered up. Okay, and the voltage would actually be like that 160 volts I got across the capacitor will actually jump up to like about 380 or 370 or 390, right? Put the meter in ohms or continuity, right? And put it in beep mode. Okay, make sure the TV is unplugged when you do this. Okay, if I hear that across the fuse, that means the fuse is good. So I know these two fuses are good right here. Okay, because we got, but this is by our power cord because we got our 160 volts across capacitors, but both of those are good, and there's one more over here. That's for a rectified B+, the 162 volts, or 167 volts. If we go to our plug, where our startup voltage is at, okay, it's missing. Most likely this one is our transformer where that voltage is coming from. So what happens is, there's voltage, DC voltage on the high side, going through this transformer on these windings on this side, all right, and it's producing voltage on this side, on the secondary side, okay, and then it's being rectified by these diodes. These are diodes. Now these transformers here are for the inverter board, okay? All right, we know that because that's what they look like, right? The two transformers, and this is the plug right here that's going to our inverter board to light the backlights up, or to light, not backlights, we have the backlights, but the CCFL lamps up. And this transformer here looks like it is actually going here. So this is our control plug right here for our inverter board. CSS feedback, LD. So what I want to check is see what is driving that particular transformer right here, okay? So all I'm gonna do is look at this transformer right here, okay? Okay, and we're actually going to follow. So this is the hot side. I'm sorry, this is the hot side, right? And this is the cold side. Okay, so we're going to follow those pins and see what is driving that transformer on the primary side. So if I'm looking correctly, look for any IC. This is going here, going through here. Don't know which is negative yet, but the positive side, we can always check the negative side by going to the negative side of the filter capacitors, which should be to the right. Okay. Meter still in continuity. Okay, that's our negative side of transformer. Okay. And the positive side, I'm going to the positive side of my capacitor. So that's what we want to follow. And it is actually going here, here, here. It's also going here. It is going to this right here, which looks like an IC. And right here, that is an IC. Right here, that's an IC. That's our transformer. That's the IC or chip that's driving it. Now they may use a 3-legged FET, okay, but this IC I believe has the pulse width modulator built inside of it, and it should be like 6 pins. What I'm gonna do before going any further is I'm going to put my negative lead. Where's my blue marker at? It's crazy. Constantly losing stuff. I'm going to go to my filter capacitors. Okay, that's a good ground for hot ground, right? And which is right here. Do not touch those with your hand. That's negative on that side, and this side is positive. Okay, and I'm going to make sure I don't have any shorts or more than one short on that IC. So let me get my Superman glasses so I can see better. All right, so I'm going to go to negative side and see my meter still in continuity. I'm going to see you got one. So it looks like a 1, 2, 3, 4, 5, 6 pins. I've only got one short to ground right here, and that's obviously going right to ground. Okay, so that has to be grounded. So that's a good sign that the IC is not shorted. Okay, now this is the most common problem on just about any dead TV set. It's going to be about 50% of your problems. The IC needs voltage to work, okay, and it uses a capacitor, right, a diode, rectifier diode, and a capacitor for the VCC or the voltage. And if we can look very clearly, we see a capacitor that looks like it has a bulge right here. Okay. That capacitor is bulged. All right. One capacitor is for the VCC, and one capacitor is for the startup that capacitor is bulged. Okay. Now one of those should be 47 microfarads. The other one could be higher or lower. All right. So let's see. I want to actually check both of those capacitors. Okay. And I can find them. Okay, CM808. And CM807. Looks like. Yep. Okay, so I'm trying to see some values here. I'm actually going to check them while they're still in the circuit. One is 47 and the other one is 100 mics at 50 volts. And one is 47 at 50 volts. So this one should be 47 and this one should be 100. All right, so let's see what we get. Put our meter in a capacitor. Okay, the 47 one, which was the one that was not bulged, looks good. And let's go to the other one. That should be 100 microfarads. That says 143. So that is a little high. What I'm going to do is I'm actually going to check the voltage on there and see if it's fluctuating. The VCC voltage should be anywhere between, I would say, 9 and like 14 volts, usually around 11 volts. Let's see. Let me plug this in and let me go across that capacitor, my meter in DC volts. DC volts. And we're going to go right across the capacitor. Okay, so let's do this one first. Okay, that's the one, the 47 volt one, I believe. And this one, be careful. Come on, stand still. That, you see that? Look at that. It is actually slowly going up. So let's go ahead and change that and see. That's a sign we got a bad capacitor, right? All right. It is slowly charging up. So let's find a 100 mic capacitor and change that out. Okay, now I know this is 35 volts, I don't have a 50, but yeah, it's always good to use the 50 or even higher. But for right now, I'm just using this for training purposes, just to see, okay, if that's going to work. And remember, there is polarity, okay. The stripe side is negative, as you see the negative sign on it, and the plain side is positive, and it should also be marked on the board, okay. If you're not unsure, just look at the other capacitors. As you can see, the shaded side is negative, so that's where our negative lead goes. You definitely do not want to get the polarities reversed, because they will explode on you. Trust me, alright? I'm gonna be on DC volts, and I'm gonna actually see if I got some steady voltage going across there now, which should be higher. And if I do, that's a good sign that I may have my 5 volts now. All right, because what happened, the voltage was too low to cut the IC on and switch the transformer. All right, let's see right here, right? Okay, reading the DC volts. There we go. Just got it reversed. 14 volts. Okay. Now let's go back to my plug. So I'm going to ground my meter on cold ground on one of these tabs right here where the screw is at, and I'm going to go to pin number 3. There it goes. 5.1 steady volts. That's it, bro. That's all we need to check. I almost guarantee you put it back in the TV, everything else is gonna work just fine. All right, guys, that's it. That's a pretty much easy one. Give you a little secret on these dead TV sets. Always check the capacitors, not the ones that were obviously replaced on here. Being very careful with myself. Okay. It looks like, okay, here's our plug right here. Looks like those capacitors were definitely replaced at some point in time. All right, right here. So always check, if you get a dead set, always check the capacitor, the VCC capacitors for the driver IC on the primary side, on the other side of this main switching transformer. Okay, always. I got a video, same problem with the TV. The capacitors were not bulged. Okay, they were bad. All right, and I replaced those, and that was it. That worked. All right, so that's it, guys. Appreciate you guys for watching. Until then, I will see you in the next one. Big Dog out.
My name is Reverend J.C. Brown. I'm a retired pastor from St. Paul African Methodist Episcopal Church in South Chicago. And I just had this gentleman fix my TV, and he did an outstanding job.
Thank you, Reverend.
You are so welcome, sir.
All right, now you're back in business with the big screen.
Yes, sir.